Highness and Your Excellencies, ladies and gentlemen, welcome to the second session. My name is Sara. I'm a professor in physical geography at Stockholm University. It's been my privilege to go with students to NEO and show them Messenia. And as I'm doing research in biodiversity, it's been really fascinating to come to such a diverse landscape compared to the post-glacial wasteland that we have in Sweden. I look forward that we will continue this collaboration to be able to show our Swedish students the fantastic landscapes in Messenia. I will be the session moderator, and the session will be about From Source to Sea, how integrated management of natural resources can drive sustainable development. And I'm happy to introduce Jakob, Granit, Director General, Swedish Agency for Marine and Water Management.
Your Royal Highness, Excellencies, ladies and gentlemen, thank you so much, all of you, for inviting my agency to participate in this event, and especially thanks to the Academy of Sciences to be here in this beautiful venue, and all other colleagues also, of course, Stockholm University, TMS, Embassy of Sweden, and the Stockholm University who have been part of organizing this. It is truly an honor to be here speaking in Athens, and this morning we had a wonderful opportunity to visit the ancient Agora and to learn a little bit more about the heart of the democracy that Athens is. And I've also had the pleasure to visit NEO in 2016 with my family. We were doing excursions there underwater, on land, and at the Observatory, so I have some background also about the geographic situation in Messina. My business here is to introduce the source to sea concept. And what is this? Well, this is in fact nothing extraordinary. The key topic we are talking about is that land, coast, and oceans are interconnected. Now, the question is how do we ensure that that is done in terms of sustainable development as well? And my agency is a rather new agency. We were established in 2011. By the Swedish government, and the reason was that we did not have a formal agency managing marine issues, and we also did not have an agency responsible for freshwater management in its totality. The agency then was created, built on a previous fisheries management agency. But in principle, we deal with three issues. We work on freshwater management, we work on marine management and spatial planning, and we work on fisheries management. So, what is it that we want? We have talked in the morning about the challenges we all can see in front of us, with severe population growth, perhaps up to 9 billion people in 2030, and rising demands for water, energy, food, and other resources. But we also know that already today there's about 1 billion people that lack basic water and sanitation, that lack also modern electricity in their daily life. So the challenge is still there to meet those needs. The green and the blue economic growth concept, in a sense, encompass these different aspects. If we want to see a new climate economy, we need to be able to grow the economy in these different areas. The blue economy is related to the oceans, and the green economy is related to what we do on land. And this topic about the green bio-based economy, we heard about it in the morning. Now, water resources, as we also heard, is a scarce commodity. Water resources span geographies. We have transboundary issues to deal with. We have local management issues to deal with. Water spans many jurisdictions. And today, we are not that good at managing our water resources. We are not that good at allocating the water resources for best purposes. So on the one hand, we have to allocate water as a principle for ecosystem services. But we also need to ensure that we manage and allocate water for primary production in agriculture and forestry. and for industry, urbanization, and domestic use, which is what we typically address. But when it comes to energy production, this is a topic which we are learning much more about now. We know that we have to utilize our hydropower systems to ensure that hydropower can be a lever for more wind and solar power. So this is something we all are learning right now. How do we allocate water systematically for best use, and how do we restore the different ecosystem services? The blue economy, on the other hand, is a rather new topic. It's been developed over the past 5 to 10 years. And this is now that we start to see that there are tremendous economic opportunities in the marine space. And this is an example from the Swedish the marine blue economy strategy, in which we are saying that we have to try to address a competitive marine industry, we have to look at the environment, and we have to develop our coastal zones. And how do we do that? Well, we have a lot of different instruments. First, of course, knowledge and innovation, but not the least, maritime spatial planning. And throughout the whole of EU, we are all together now planning our common oceans. So, for example, in our case, in the Baltic Sea region, we plan the ocean space together with 9 countries. We are looking at issues as energy, transport, marine spatial zones for nature reserves. We are looking at mineral extraction, transport, of course, and defense. Some of these key issues that are now coming together, which we need to see how we can develop. But these are all good economic and ecosystem concepts. So what then is actually happening? Are we achieving this at scale? Just to give you a few examples of how it looks. Now, this map here shows that freshwater systems are really rapidly degrading at a global scale. And we see that 80% of human population are today living in water scarcity or in water hazardous regions. So we have developed our water systems. We have dammed the rivers. We have developed our agriculture. And these are now impacts on our livelihoods. So we have to address this because we also know that we need the water resources for our development. And how does it look in the coastal zones? The same issue we can see here. We can see that our coastal zones are rapidly degrading. And the white spots you see on these maps, they represent eutrophication, areas where we have anoxia, areas where we have dead sea bottoms along our coastal zones. Typically, we can see these white dots in the industrial areas, but we can now see them spreading around the globe. So, if we want to have sustainability, if we want to have fisheries, we have to address these issues. And finally, how does it look in the marine space? The global oceans are suffering. They are suffering from acidification. They are suffering from plastic pollution. They are suffering from toxic substances. We all know that story. But the horrible part of that is that there are actually no area, essentially, on the globe that are not impacted today by anthropogenic activities. So these are serious issues, and they connect. And finally, I'll not dwell too much on that, but on the climate change story, we can see that climate change is accentuating and making these issues become more rapidly and more severe. Severe storms, rising sea levels, acidification and heat waves that bleach our coral systems. So this is all happening right now as we speak. But this is not a doomsday scenario. This is about what can we do differently. And we think that the heart of the matter is perhaps not the physical sciences, because we know a lot today, but what we don't know much about is the governance and the management systems. Already Ptolemaios, as I figured out, in the year 150, knew that the Nile was connected to the 2 great lakes in the central part of Africa, and that the river was flowing to the ocean. So it's not new that land connects with freshwater, estuaries, coastlines, adjoining sea shelves, and open sea. And it's also not new that we need to have freshwater systems here. We need to have healthy food from these systems. We also know that water, sediments, pollutants, biota flows, and materials connect. But what we don't know is how to manage this. What type of systems do we have when we talk about, for example, urban planning linked to watershed planning, linked to protection from rising sea levels, linked to our larger watersheds. Take the Nile, for example, with 11 riparian countries. How do we manage these very, very complex systems? And that drains into the Mediterranean or the Baltic Sea with 9 to 10 or even more littoral countries that has to work together. So that's a research area that we need to figure out. How do we get these different geographies and different management systems to work together in a coordinated way? We have to work deep in certain aspects, but we also have to be much better at looking at coordination across geographies and across different management silos. So a few examples of these key flows that I talk about. And there are many. And depending on where you are, one can assess these flows to see what to do, what type of measures to take. But these are just some examples. On the water flows, we know that we have fragmented governance and management, that we are not managing our river basin system as a whole today. And we are not also managing our marine system as a whole. In fact, 40% of the global oceans do not have any management system today. We have good frameworks. We have the EU Water Framework Directive, and we have the EU Marine Spatial Planning and Marine Strategy Framework Directive, but they don't connect. They overlap at the coastal zone, so we do not know how to manage these interlinked systems. We plan them separately. And then at the national level, we continue fragment the governance of our water resources. So this is a challenge. Sediment flows. We know that we have too much or too little sediments in the coastal zones. We have severe erosion in the Messina area, but also along the southern eastern part of Sweden. But we also know that there are very many smart green and blue infrastructure investments that we can do, that there are multiple solutions, and that we need to connect the upstream and downstream connectivity issue. Pollution flows. We also know today that about 80% of the global sewage is untreated. 80% of sewage goes to the coastal zones without any basic treatment. So this is something that has to be addressed. And we know the plastic problem. We know about the plastic jars in the large part of our oceans, and 43 million tons enter the oceans every year. But there are many issues that we can deal with already today. We can implement solid waste management and recycling. We can ensure that there are sanitation technologies that includes dry sanitation with less impact on water. So technologies are there. The question is, how do we implement them? We know that our fish and other species migrate from the marine space to the freshwater aspect. The Swedish salmon, for example. We have lost about 12 of our 35 different species of salmon due to development of hydropower. And I don't know how it looks in Greece, but there probably are similar connectivity issues. We need to ensure that fish can migrate up and spawn in the river areas and be part of a productive fisheries management system in the open sea later on. If we cut that link, then there will be no connectivity, there will be no fish in our rivers, in our oceans. We have to take a much more of an ecosystem approach to management of our fisheries. And material flows. We had a fantastic presentation about the development in Stockholm over the past years, but we see that it's a rapid development in our coastal zones now. Cities are developed in a very fast pace, and how do we protect them in the future? And how do we make them sustainable? And not only cities, we also see that aquaculture, large-scale aquaculture, is moving from the coastal zone out into the open ocean with severe impacts with nutrients and other issues that will impact our future sustainability of the oceans. Technology is moving fast. We have new wind turbines that are the size of the Eiffel Tower, 10 megawatts each, that are now being put out in the ocean space. And it has to be done right, in the right spot, to take advantage of this. And finally, we have to keep the eye on the target here. What are these ecosystem services that we so badly need? The clean water, the healthy food, the renewable energy system, the pollution reduction, the aesthetic environments for tourism, and the resilience to climate change and weather variability. These are the things that we need to understand, and we need to see how to find out how to manage these systems in very, very complex political and economic different parts of the world. So with that, as a conclusion, as an introduction to this topic, the connectivity between land and oceans, and some of the issues of how we can deal with that. And I believe we will hear a lot of good examples now here in the next sessions on different geographies. But at the end, green and blue economic opportunities are really large. We have to see what are these clear objectives when we find these solutions, and we have to look at how to coordinate across sectors and geographies. It sounds easy, but it's not. And goal number 6, 14, and 15 in our Sustainable Development Agenda can guide us. Thanks so much.
Thank you, Jakob. Now I will introduce some examples from the EU Coastal Collaborative Land-Sea Integration Platform, co-creating evidence-based business roadmaps and policy solutions for enhancing coastal-rural collaboration and synergies. And our first speaker is Giorgos Destouni, professor and head of the department at Physical Geography at Stockholm University. Please, welcome.
Your Royal Highness, Excellencies, ladies and gentlemen. So I will continue now from the general and global perspective that Jakob gave to a more regional EU perspective, and I will do that through the coastal project that Sara introduced, so Coastal Collaborative Land-Sea Interaction Platform. Sorry. There we have it. And this is a European Commission Horizon 2020 project ongoing with NEO and Stockholm University as important parts in the project that also includes 30 partners in total. You see their logos up there in the picture. It's around 30 partners. As the name indicates, coastal, the focus is here on coastal areas. And why? Why have such a huge EU project on coastal areas? Well, the source-to-sea concept that Jakob introduced, this goes doubly and triply in coastal areas because they integrate sources, activities, pressures from land, activities, pressures from sea, and from climate are all integrated in these coastal areas with the highest populations around the world. That's where people concentrate. That's where big cities grow even bigger. In spite of this importance of the coastal areas, they have been rather neglected as areas per se in research, because one looks at land or one looks at sea, but the coastal areas are in between. So this project now wants to take a focus on these particular areas. And the goal of the project is to, through this research, to contribute to sustainable coastal and rural land development in coordination. So we are looking in this project both at environmental and socio-economic interactions, land, sea, but also climate. The project gathers a lot of different stakeholders, businesses, such as agriculture on land, fisheries in the sea, administrations, NGOs, and natural and social scientists. And it also integrates local and scientific knowledge in order to identify key problems and find solutions, develop or contribute to developing strategic policy guidelines and business roadmaps towards such a sustainable development together. And to do so, the project looks at and integrates 6 coastal case studies, which we also call multi-actor labs because they involve so many different actors to co-create the research. So these 6 areas represent and link major coastal regions in the EU territory, and you can see how they are spread. From a NEO perspective, we are of course, particularly involved in the coastal areas that the number 2 and number 3 here, where number 2 is the Messenia coast, where Neo is located, and number 3 is actually a cross-scale case, where we look in particular at the Stockholm area and the land area that drains into the Baltic Sea through Stockholm, right in front of the Royal Palace, actually, at Norrström. But we also take this further to look at the coastal zones around the whole Baltic Sea. So these 2 cases represent very different scales, where we have a local scale in Messenia and we have a large and very large scale in the Norrström and Baltic case. The Baltic case is already highly affected. The coastal waters are affected by, and the marine waters, by eutrophication and pollution. And the question here, the problem is how to achieve further growth and development while solving these environmental problems. And in the Messenia case, we also seek economic development or growth while not creating such severe environmental changes and deterioration. So the aim here is to learn from each other, use similar methods across the different cases, and try to find solutions together. And this research is very consistent. This is one project, but this project is entirely consistent with what we aim at with the NEO research. And it is, one of the aims here is to make Greece and the Eastern Mediterranean region in particular as key nodes in international research networks towards sustainability. And to link, in particular, the NEO area, the Messenia, with other research sites in Sweden, across Europe, and the world. So my colleagues that will follow here, they will present more about the specifics of research in the Messenia case. And I will just go to give some examples of research results that aim to do particularly that, place Greece, Eastern Mediterranean region in the context of whole Europe and the world. So this is just one example of results where we have looked all over Greece and looked at how temperature, precipitation has changed, but also so climate has changed, but also how irrigation developments, in particular agricultural developments, have occurred in the country from the first half to the second half of this century. And just as example results, you see here in the graph how runoff has decreased over this time. And the total decrease are these red bars, where you can see the total, that means whole of Greece. And there we have a decrease close to 80 millimeters per year, which is a substantial amount of water that no longer runs off to the sea through the streams and rivers of Greece. And then you can see different parts of Greece in the other bars. But what is interesting also here is that we have been able to distinguish the effect of atmospheric climate change, so the change in temperature and precipitation that Professor Zerefos talked about in the morning, where we have had a substantial decrease in precipitation over Greece, but not as much as the runoff decrease, because in addition to the precipitation decrease, the irrigation developments have added more or less the same amount of effect of increase in runoff. Now, that component, those are the green bars, show the irrigation development contributions to the runoff decrease. But of course, that water is not wasted unless the irrigation practices are very wasteful. But in principle, that water goes to feed the plants, the agriculture, so it is made useful. But as liquid water, it goes away from this area. It goes away from Greece, because it does not add to precipitation here. So this is a trade-off that we need to think about when we manage water. You know, how much do we use for agriculture and how much must be left for other sectors in the environment? We have also talked about droughts here today, and here is a map over Europe showing dryness index, where we can divide Europe in 3 essential climate zones. We have the north that is wetter, the central Europe that is, a little bit less wet, and we have southern Europe that is dry. And what you see in the graphs to the right here is how much is the water deficit. We have looked at droughts occurring over the whole of Europe the last 30 years where we also have satellite data, because otherwise there is a severe lack of data in this region. And we can see that the southern Europe, that climate zone, the typical water deficit during a typical drought goes up to around 120 millimeters per year less than normal under non-drought conditions, whereas up in the north we are around 60 millimeters per year, a typical deficit. That's why here droughts strike much more towards agriculture. They start affecting plants and not just the flow in the rivers. And this is what can be counteracted with irrigation. So these are trade-offs to think about when we want to manage water. So I want to just end with mentioning a couple of other European projects that we have landed since Coastal started, and those are in the program for European cooperation in science and technology. One of them is Damocles, that is about understanding and modeling compound climate and weather events. And what the compound event is an event of combination of processes that lead to high impacts, because an accident seems to never come alone or seldom come alone. So there are always, we may have heat waves leading to droughts and further to wildfires, and then on top of that, flooding directly after. These are compound events leading to these, and we want to understand these high impact events, and there are scientists all over Europe collaborating in this project to try to come forward in this. The other also new project, cost project, is FireLinks, and that has to do with fire in the Earth system, science and society, where the aim is to understand the intensification and try to counteract the intensification and the geographical spreading of wildfire regimes under the ongoing change that now actually spreads all over Europe, and we have started to feel what that means also in Sweden in recent times. So with this, I end my presentation of,
Thank you. Now we've got this broad overview, and we will dive down more local and regional. And to continue to do that is Aris Karageorgis, Research Director and Director of the Institute of Oceanography, Hellenic Center of Marine Research. Please.
Your Royal Highness, dear guests, colleagues and friends, good evening. As Sara said, we're going to have a change of scale. Previous speakers have talked about the entire globe, Professor Zarefos. Then we had the introduction about Europe, and I'm going to navigate you a little bit, not only to Greece, but its southwestern part, and not only Messenia, but its northwestern sector. So we are talking about a tiny bit of land which concentrates our interest within the study of coastal. I thought it would be a good idea, since talking to such a wide, let's say, audience, to give some definition about what we are looking for and try to define what is a watershed. A watershed, or a catchment area, or a catchment basin, is what you see here in the picture, is the piece of land which gathers water coming from the atmosphere, from rain and snow precipitation, which is good because it feeds the rivers, the creeks, the torrents, which eventually end up to the sea. And this is the good part. Among with the nutritious substances that end up to the sea, we have also whatever happens with man activities, which carry anthropogenic pollutants of various kinds, organic and inorganic substances, into the water, which eventually ends up again to the sea. To the interface between the land and the sea, we have the coastal zone, the part that we are strongly interested within coastal project. So what you have to keep as a message from this small slide is that whatever happens in the catchment, let's say a few kilometers inland or even further, has a direct effect and impact on the coastal zone and the sea, although most of the people does not know that such a relation exists. Just to give you two typical examples of how land and sea interactions behave, on the left panel I show you some ugly green waters. It's the part of the sea that suffers the phenomenon of eutrophication. In the Baltic, it's a very common phenomenon. In the Eastern Mediterranean and in Greece, it's less known, but it still exists in some areas. What happens here is that we have agricultural substances like pesticides and fertilizers that end up to the coastal water body, and these substances are often nutritious. They are good for the environment with respect to phytoplankton growth. So we have small plants, phytoplankton, that grow, but grow too much, they overgrow, and this overgrowth creates the eutrophication problem. And it's not only the aesthetic part, it's also the deficiency of oxygen, the massive mortality of organisms, and much more. So you have to remember that all this is coming up from the land area and is affecting the sea. Another example, now coming from Côte d'Azur in southern France, is the coastal urbanization. As tourism expands and everybody wants to have a nice, let's say, summer or a few weeks off to relax around the beach, we have massive construction of buildings, hotels, sometimes in an anarchic way, which create a lot of stress to the coastal zone. One common phenomenon is that the land is changing prices. So for some people who still go to continue with farming, they have to deal with high prices of land. On the other hand, we have multiple constructions that are built along the coast, which create, as the previous speaker said earlier, severe erosion problems. And I want to give you an example. We use it in my work as an anecdote. We're working in the field in northern Peloponnese, and we were staying at a hotel. The hotel at this part of Greece suffers from loss of sand, and the sea was actually knocking on the front wall of the hotel. So the hotel owner was complaining. He said, the state has to do something about that. They are not protecting me. My fortune is going to be destroyed. However, during discussion, we realized that this guy, despite of being a hotel owner, he also was having a unit which was excavating sand in a riverbank a few kilometers upstream. This work on the river has a direct impact not only on the beach, but on his own hotel. This guy was taking the sand that belonged to his beach, and the sea was taking a revenge, and it was taking out his hotel. It's not a good example for someone to lose its fortune, but it brings up the principle of what is happening inland affects other people, and those people don't know how to interact and resolve these problems together. And this is a small effort that we are trying to do here in this project. It's a small case study, okay? As we say in this project, we have large-scale surfaces, like the Baltic, and here we have a piece of less than 200 kilometers of land with a typical nice Mediterranean climate and nice temperatures and relatively high precipitation for Greece, around 700 millimeters. It is a rural area. All the colors that you see in the image show different kind of cultivations, but the majority, as we're going to see later on, is olive trees. We have to note that some villages are there, small villages, but again, sewer treatment is not existing, and this happens globally in some cases. We have a connection to the Ionian Sea, which is a deep sea. It's going down to 5 kilometers. A few kilometers southern, we have the deepest place of the Mediterranean, which is 5,150 meters deep. And I regret to tell you that we know very little about it. The deep sea is the mostly unexplored part of the planet, and the Eastern Mediterranean, unfortunately, is part of this, let's say, unknown territory. We have a high cultural value because we have nice archaeological sites in the area, and we have also Natura sites for protected areas. I give you some nice pictures of famous beaches and the castle of Methoni to the south and the olive trees. As we said, we have mainly agricultural activities in the hinterland, olive trees. It's supposed to be one of the areas producing some of the best, or for some people, the best olive oil in the world. And we have also very intense coastal tourism. Nevertheless, we have a number of pressures. Okay. We have, in some cases, decrease of biodiversity, which is related to some kind of pollution, not heavy pollution, but it is there, which has to do with contamination of human waste, pesticides, fertilizer, and other things. We have also agricultural practices interfering with wetlands. The picture that you see down to the left is connected to a wetland, which is receiving a lot of anthropogenic pressure. We don't have, let's say, substantial management projects to monitor and protect the Natura 2000 sites, but this is an ongoing process, and it's going to be developed, I hope. We have, of course, traffic, water demand, and other normal, let's say, issues for areas that are heavily affected by tourism. And on top of all this, we have, as previous speaker said, the climate change, which is affecting the entire territory, and modeling foresees less precipitation of water. In the long-term objectives, we have plans for, of course, tourism expansion, which is something that we are looking after, but also there are discussions about offshore oil and gas production. Now we are at the exploration period, but there are hopes that large quantities of gas and maybe oil will be discovered. So we have to think this as a potential threat for the entire area of the Ionian and southern Crete, that something very big might happen offshore that will affect the other way around. Now, from the offshore, you're going to have impact near shore. I will give you just 2 examples to tell you how this is going to work, because in fact, it's a fairly complicated scientific dive into the relations between people, enterprises, and science. So using olive farming as, let's say, a driver, which is a make economic activity, we have to accept that there is a risk that agriculture, that often has to do with soil changes and removal of vegetation, and also use of fertilizer, might have an effect on the coastal water quality. What we see in this is an opportunity, and this is the way around. If we come out that upgrading the farming conditions, let's say, for example, not take it as a granted, but let's say, for example, that we switch gradually to organic farming. This is going to reduce chemicals, it's going to improve the quality of the water, the streams and the coastal zone, but on the other hand, it will increase the prices. So through this kind of process that we're going to apply, we're going to evaluate these kind of changes if they're going to be productive and beneficial over the years. To give you a small scientific information, this year we studied carefully the area because we are doing some analysis on the impact of olive mills waste into the small creeks. This, unfortunately, for a lot of people and the scientists as well, was a bad year. We had very low production because of some local disease, so the phenomenon was not, let's say, created, and we were not able to measure this kind of substances. But nevertheless, we did some good science on the field. Another example, and I'm going to stop with the examples here, is tourism, which of course is the economic activity that we seek for, but it has to be done in a sustainable way, because there is a risk, irrigation practices, increase of water demand, and also lack of water in the next coming years is creating water scarcity and might create problems in the local communities. So what we have to do is to find solutions, how to exploit water in a better way, how to recirculate water. So whatever is a risk, at the same time is an opportunity when you have science and new technological advancements that can lead you to the future. To do this, to try to organize all these thoughts all together, we have organized sectoral workshops in coastal. And the first aim is to try to put people around the table to discuss. Okay, so we have collaboration between different parties which normally do not sit around the table and talk. Usually they disagree and fight. But with a friendly atmosphere at NEO, everybody was in place and we had very good discussions. The second thing that we want to do through this project is to manage to collect and exploit different kinds of data that exist, but they are not so well structured, and also take advantage of the experience of local people who are very experienced and know a lot of things, and they can transfer to us scientists this kind of information. We want to discuss about business plans, specifically those ones which have the synergy effect between land and sea together. And of course, one of the basic actions is to disseminate knowledge. We have identified that one of the major issues that is of concern is the lack of communication between different parties. So we have to bridge that gap by any means. And this is the number of workshops and the major titles that we have conducted since last July. All of the workshops were hosted at NEO facilities. Everybody had a great time. And I'd rather not talk longer about that, but I will pass the floor to George to give you more details about the methodology that we have applied. Thank you very much.
Thank you very much. And then we will have our final speaker to talk a bit about the local engagement. Giorgos Maneas, who's the manager of the station manager of the Navarino Environmental Observatory.
Thank you very much, Sara. Your Highness, dear guests, we are talking about so many interactions, and you will understand later how many, which are related to population growth, water resources management, environmental protection, infrastructures, policy legislation, and of course, under ongoing climate change and under a rather unstable economy. And we have these sectors that Aris mentioned because this is our system. This is what we have down there in Messenia. We have agriculture, tourism, we have a great landscape, we produce very nice products, and all this we need to manage together. So far, we have completed 6 workshops, bringing together more than 70 stakeholders, and this is more or less how I look when we do the workshops. And, okay, I'm not that fast, but we have managed to do, to mind map the perception of farmers and agronomists, the perception of the local industry, of the tourism sector, the public sector, of course, institutions and NGOs, and the fishermen. And if you look closer, it is a mess. And this is how we all thought at the beginning. But actually, it's not a mess. It's quite a constructive way to categorize and understand how our stakeholders perceive the interactions within their sectors and also in connection to the other sectors. And of course, we have tools to simplify these models. We have tools to add numbers into these variables. And we can feed system dynamic models, which are models will come back with some solutions which will need to come back to our stakeholders for validation, back and forth until we get a match. And this is how we can validate this model, and this is how these models can be used, how? In a broader concept, because we are collaborating with other 5 areas with different but also similar interactions. And it doesn't matter if it is a remote island or if it is a heavy industrial zone, if it is local or global. The principles to approach the system are exactly the same. And what we have learned, of course, there is a lack of communication, but it was highly appreciated by the stakeholders. And this has never happened before in our area. And of course, we need to bring together science, policy, and interaction, and we need to start working together to co-achieve our goals. And all of us working at NEO, we really think that we are into that direction. And it would be great to see more NEOs coming up tomorrow. I hope that I didn't do it too fast. Thank you very much for your attention.
Okay, thank you. I would like to ask a question first. We so ahead of time, almost. So I would like to ask a question to Jakob. Do you have any good examples where this sort of concept has worked to manage watersheds?
Thank you. We have been working on this concept on a global scale for many years and published a lot of different case studies. But something that we work on right now in Sweden, I think, is encouraging. We have about 2,000 hydropower plants in our country, and they have been developed for the past 100 years into modern electric system, which supports 50% of the electric system in Sweden today. But as I mentioned earlier on, of course, the connectivity in all those river systems have been lost towards the ocean, with severe impacts on fisheries, coastal zone development, erosion, and all these problems that we heard. So now, we are now in a phase with new legislation to go through all of those 2,000 hydropower plants and provide them with modern environmental permits. So they have to go through a judiciary process. But when we are doing that, for the first time, we're actually looking at, we are clustering all those power plants in different watersheds, talking about the watersheds, to see the connectivity between them in the river basin, and then also towards the coast and the oceans. So while we now are removing, in some cases, some of these obstacles, and or retrofitting them with fish ladders and other systems, we're also then coupling other public and private resources into watershed management as a whole. So with that perspective and linking then fisheries management to that, we can now start to see how we can recreate the habitats for the eel, the European eel, which is one species for the whole Europe. We are looking at salmon migration, how we can restore the salmon habitats upstream and downstream, which creates opportunities for sport fishing and also for local artisanal fisheries along the coastal zone. And we are looking at other fish species and how they migrate up and down the river systems, which we didn't even know before, like pike and sea bass and others that are migrating up and down at an extent we didn't even know. So that's one way of looking at these different systems together: fisheries management, energy system management, and also then watershed management as a whole. But it's early days, and we also lack in Sweden a robust watershed management system, which we have to look at, because we also suffer from drought now, as everybody else is doing. So that, a couple of promising examples, but also a caveat that there's much more to do.
It's nice. You talk like a landscape ecologist, what I'm doing. So do you have any examples from the coastal, how to engage the local people to engage in this complex system, with an excellent example from Aris?
Well, in fact, we did exactly, that's the whole point of coastal, because exactly the same thing that was done in the Messina case, we did for the Norrström and the Baltic case. So we also had 6 sector workshops and gathered people and made these mind maps and then merged them into a system model that can be actually quantified, that we will now meet again with the stakeholders to go through. And in fact, we had exactly the same reactions from the Swedish and Baltic stakeholders, that they were so happy to meet in this way. And they had never experienced anything like that before, and they were very happy to see, because we were doing the modeling at the same time as we drew on them. And yeah, they were very intrigued. So we will meet soon and go through the simplified map, that type of, that Giorgos. Now, will this be a successful example? That remains, we're in the first year of coastal, but that's the aim. But at the same time, if we take the Baltic case, I mean, we have had the eutrophication problem there for long. We have tried all kinds of measures, and we still see very little results. So what we are doing in parallel is also to try to map every catchment, every data that has data that we can analyze and see where have improvements occurred and where have they not occurred, and try to understand the characteristics of the cases where we have actually seen improvements and how they differ from where we don't see any improvements. And we hope by this very detailed characterization work that we will be able to find a recipe for success, where it's still early days, like Jakob says.
Okay, thank you very much. I'm afraid we just caught up very short.
Just something little short, but of essence. The great, let's say, success of Coastal is that it has engaged the stakeholders right from the beginning. In the previous European Union funded project, we were, as scientists, trying to approach stakeholders, like Achilleas Konstantakopoulos here, to try to engage. Now they are engaged from the beginning, and this is the success. If you have people right from the very start sharing the same ideas and the same problems as you do as a scientist, there is a great possibility to succeed.
Thank you. I really look forward to see the results. And by that, I conclude this session and leave over to the next session. Johan Kylastierna.
Thank you very much. Really interesting, and a lot of practical examples of what you actually can do to try to apply some of the concepts we have been talking about here today. So, Your Royal